All right, so one last bit of formal power series manipulation. This is less important than the others. I think it's really interesting about how this works, so I thought it would be a good thing for me to talk about. So when you're dealing with formal power series, you are allowed to interchange derivatives and derivatives and sums or integrals and sums. When you're dealing with actual series, you have to be careful about these things, you have to be careful about convergence. But with formal power series, we're less careful. So, for instance, if we have these sums and integrals, the sum of k greater than or equal to 0 of the integral of 0 to the x of x to the k, well, we can interchange the sum and the integral at that same time. So what that's going to give us is going to give us an identity. If we integrate x to the k as a function of x, what we get is x to the k plus 1 over k plus 1. And I've kind of been a little bit, not sneaky, I've just been a little bit lax with my rules here. I've made this a definite integral, so there's no plus c. That's already taken into account in what I've written here. And so that's what this integral gives us, x to the k plus 1 over k plus 1. And so what we can get is we can get a formula for the sum k greater than or equal to 0 of x to the k plus 1 over k plus 1. So let's actually do that. We get this integral now of the sum. So we get the integral from x equals 0 to x of 1 over 1 minus x dx. And when we integrate 1 over 1 minus x, we get negative ln of 1 minus x. And then we plug in the x, we plug in the 0. And so this sum on the left-hand side is going to give us this sum on this compact generating function on the right-hand side. All right, and we can do the same thing. We can interchange derivatives and sums as well. So this derivative of x to the k, well, the derivative of x to the k is kx to the k minus 1. And so what this is going to allow us to do is get a formula for the sum of k greater than or equal to 0 of kx to the k minus 1. So that's going to be then the derivative of 1 over 1 minus x. And so that's equal to, well, this is 1 minus x to the negative 1 power. So when we take the derivative, we get 1 over 1 minus x squared, with the negative 1's canceling out. All right, and so you'll notice this looks a lot like our sum that we had for the fruit baskets, right? This is going to give us the sum of, right? This is just another way to get this same formula, that the coefficient of x to the k is k plus 1. All right, and so you'll notice what happened here is that if I look at this, the factor in front, the coefficient of x to the k minus 1 doesn't really match up with the exponent of x to the k minus 1. So what we're seeing here is that, let's say we wanted these to match up. Let's say we wanted the coefficient to match up with the exponent. What we're seeing is that we kind of need to bring in an extra value of x. So if we have sum of x to the k greater than or equal to 0, and we want to change that and compare that to the sum k greater than or equal to 0 of kx to the k, well, to get from here to here, we would take the derivative. So take the derivative of x to the k. So that gives us kx to the k minus 1. And then we would multiply by x. And that would give us kx to the k. All right, and so what we get then is that from here to here, we have to take a derivative, and we have to multiply by x. So this always makes me think about Charlie XCX. Here it's x ddx. So whenever you want to extract or bring down a k in front of an x to the k, you have this operation that's x ddx. So if we have something that's the sum of k squared x to the k, well, that's the same thing as doing x ddx twice. So if we take the derivative, so what we have, if we took x to the k and then took the derivative, you get x times kx to the k minus 1, so x ddx, and then we bring in that x, we get kx to the k, and if we take the derivative again, so the derivative of this now is k squared x to the k minus 1 times x, so we get k squared x to the k. So what we're seeing is that this sum is going to be equal to x ddx of x ddx of 1 over 1 minus x. Okay, so let's go through those steps. So the derivative of x ddx times x ddx of 1 over 1 minus x is equal to x times ddx of x over 1 minus x squared. The derivative of this, so we'll have to use the quotient rule. Low d high minus high d low times negative 1 over low squared. So what is that? That's 1 minus 2x plus x squared plus x squared minus x to the third, all times x. This is x times 1 minus 2x plus 2x squared minus x cubed. And so this sum, it has as its compact form x minus 2x plus 2x squared minus, x minus 2x squared plus 2x cubed minus x to the fourth over 1 minus x to the fourth. And what we're seeing is that if you have any generating function, like a of x is equal to the sum of a sub k x to the k, and you actually have some polynomial of k in front of you, then the way you bring out this polynomial and do some algebraic manipulation to it is you think of this polynomial as p of x ddx of ax. Those are some more advanced techniques in formal power series manipulation. All right, talk to you later. Bye.